From the dawn of time, space has been a source of wonder and terror. It cradles our planet, nurturing life with the warmth of the sun, yet it also harbors dangers that can extinguish civilizations in the blink of an eye. Lurking within its depths are celestial wanderers, asteroids. These remnants from the birth of our solar system hurtle through the void, and their paths occasionally intersect with our own, sometimes with catastrophic consequences. One such catastrophic encounter occurred 66 million years ago, forever changing the course of life on Earth. Today, we stand at a crossroads, armed with the knowledge and tools to potentially avert such cosmic disasters. Join me as we delve into the fascinating and sometimes unsettling world of asteroids, exploring their destructive power, the threat they pose to our planet, and our efforts to defend ourselves from these celestial wanderers. Imagine a day 66 million years ago when the dinosaurs roamed under a pristine sky. Life, in all its magnificent diversity, flourished. But high above, unseen and unheard, an asteroid larger than Mount Everest hurtled towards Earth at a speed of over 40,000 miles per hour. This celestial harbinger of doom slammed into the shallow waters off the coast of what is now the Yucatan Peninsula in Mexico. The impact released an energy equivalent to billions of atomic bombs, gouging a crater nearly 110 miles wide and 12 miles deep. The shockwaves triggered earthquakes and tsunamis, reshaping coastlines thousands of miles away. The immense energy released superheated the surrounding rock, vaporizing it into a searing cloud of gas that expanded outward at supersonic speeds. This incandescent plume ignited wildfires that raged across continents, turning vast swaths of lush forests into smoldering wastelands. Trillions of tons of pulverized rock and dust enveloped the planet, blocking out the sun and plunging the Earth into an extended period of perpetual twilight. The prolonged darkness had a devastating effect on the planet's climate, leading to the collapse of food chains both on land and in the oceans. The Chicxulub Impact serves as a stark reminder of the immense power of asteroids and the profound impact they can have on our planet. The Chicxulub Impact might be the most well-known example of an asteroid's destructive power, but it's certainly not the only time our planet has been struck by these celestial wanderers. Earth's history is peppered with countless collisions, some leaving behind scars still visible today. One such period of intense bombardment, aptly named the Late Heavy Bombardment, occurred roughly 4.1 to 3.8 billion years ago. During this tumultuous era, our young solar system was a chaotic shooting gallery, with countless asteroids and comets raining down on the inner planets. The evidence of this ancient bombardment is etched across the face of the moon, its surface pockmarked with countless craters. Earth, with its active geology and erosion, has largely erased the visible scars of this early period. Fast forward billions of years, and we arrive at a more recent event, the Tunguska event of 1908. On the morning of June 30th, a blinding flash of light illuminated the skies over Siberia. Moments later, a deafening explosion, estimated to be 1,000 times more powerful than the atomic bomb dropped on Hiroshima, ripped through the air. The explosion flattened over 80 million trees over an area of 830 square miles. More recently, in 2013, a meteor entered the Earth's atmosphere over Chelyabinsk, Russia, exploding in a blinding flash of light. The Chelyabinsk meteor highlighted the very real threat posed by even these smaller asteroids, reminding us that even in the 21st century, we are not immune to the capricious nature of our cosmic neighborhood. Chapter 3: Guardians of the Planet Tracking Near-Earth Objects. The dinosaurs met their demise because they lacked one crucial ability. They couldn't see the asteroid coming. We, on the other hand, have the power of foresight, thanks to the tireless efforts of scientists and engineers around the world who are constantly scanning the skies, searching for any potential threats lurking in the cosmic shadows. At the forefront of this planetary defense effort is NASA's Center for Near-Earth Object Studies, or CNEOS. This dedicated team of astronomers, using a global network of telescopes, is tasked with a critical mission to detect, track, and characterize any asteroid or comet that comes within a certain distance of Earth's orbit. These celestial objects, collectively known as near-Earth objects or NEOs, are remnants from the early solar system, their orbits influenced by the gravitational pull of the planets, sometimes bringing them perilously close to our own world. CNEOS acts as Earth's first line of defense, constantly monitoring the skies for any potential threats. The process of hunting for NEOs is a meticulous and challenging one. Astronomers use powerful telescopes, equipped with advanced imaging technologies, to scan the night sky, searching for any points of light that move against the backdrop of stars. Once an NEO is identified, its trajectory is carefully plotted and its potential to pose a threat to Earth is assessed. While the vast majority of NEOs pose no threat to our planet, even a small chance of impact warrants careful monitoring. The size of an NEO plays a crucial role in determining its potential impact. Chapter 4. Averting Armageddon, Earth's Planetary Defense Plan. For millennia, humans could only watch the skies with a sense of awe and trepidation, at the mercy of the cosmic lottery. But we are no longer passive observers in the face of cosmic threats. We're now entering an era where we possess the knowledge and, increasingly, the technology to protect our planet from asteroid impacts. One of the most promising strategies for deflecting an asteroid is NASA's Double Asteroid Redirection Test, or DART mission. This groundbreaking mission, launched in November 2021, represents humanity's first attempt to deliberately alter the course of a celestial object. The target of the DART mission is Dimorphos, a small moonlet orbiting a larger asteroid named Didymos. The mission's goal is to crash the DART spacecraft, traveling at a speed of over 14,000 miles per hour, into Dimorphos, slightly altering its orbital period around Didymos. This kinetic impact technique relies on the principle of momentum transfer. The DART mission, if successful, will provide invaluable data on the effectiveness of kinetic impactors as a planetary defense strategy. Scientists will carefully monitor the Didymos system after the impact, measuring the change in Dimorphos's orbit and studying the crater created by the DART spacecraft. But DART is just one piece of a much larger planetary defense puzzle. Scientists and engineers are exploring a range of other deflection techniques, each with its own set of advantages and challenges. Chapter 5. The Future of Life on Earth, Our Cosmic Responsibility. As we gaze out into the vastness of space, we are reminded of our place in the cosmos. We are inhabitants of a small, fragile planet, orbiting a star we call the Sun, one of billions in the Milky Way galaxy, itself just one of countless galaxies scattered across the universe. Our existence, as far as we know, is unique, precious, and utterly dependent on the continued habitability of our planet. The threat of asteroid impacts is not a matter of if, but when. It's a cosmic certainty that Earth will be struck by asteroids again. However, unlike the dinosaurs, we have the ability to see these threats coming, to understand them, and to potentially avert them. The knowledge we gain from missions like DART, the ongoing efforts to track and characterize NEOs, and the development of planetary defense strategies are not just about protecting ourselves from cosmic threats. They are about fulfilling our responsibility as stewards of our planet, of preserving the legacy of life that has unfolded on Earth for billions of years. We have the opportunity to use our knowledge, our technology, and our collective will to ensure that the story of life on Earth continues. Let's choose to act, to protect our planet, and to ensure that the story of life on Earth continues for millions of years to come. Our cosmic legacy, defending Earth, preserving life. Dinosaurs didn't see it coming, but we can. We have the power to change the course of history, to rewrite the ending of the dinosaurs' story. We can choose to become the guardians of our planet, the protectors of life, not just for ourselves, but for all future generations. NASA and space agencies around the world are working tirelessly, pushing the boundaries of science and technology to detect, track, and deflect asteroids before they can harm us. These efforts are not driven by fear but by hope, by the belief that we can overcome even the most daunting cosmic challenges. Asteroid threats are real, but with science and technology, we have the power to prevent another mass extinction. The future of life on Earth, the fate of our species, rests in our hands. Let's choose to act to protect our planet and to ensure that the story of life on Earth continues for millions of years to come. Would you like to see a real-life asteroid defense mission? Let us know in the comments.